guest speaker, Sir Inamul Khan. So, sir, I would like to say some words from Engineer Talks to our audience that the aim of Engineer Talks is to fill the gap between industry and academia. It is a tagline that we use, and I would like to invite our guest speaker, Sir Inamul Khan, to continue the session. Thank you so much.
Okay, thank you so much, Harchand. And this section will be like really a good section for especially for the research students, I will say, because today is the era of modernization and technological innovation. So I think that this topic will be the new thing for the especially for the researchers, and if someone wants to learn about like the future warfare, like especially like we selected about the drones and artificial intelligence. Firstly, I will tell you a little bit about myself. My name is Inamullah Khan. As earlier Harchand announced my name as well. I'm currently a faculty member at the ZBIST Islamabad at Department of Computer Science. Also having one of the prestigious platform that is I'm the founder over there, which is AI Explain You Science. We are having some honorable. We are having some good PhD doctors and postdoc researchers. Where we are doing some sort of collaborations in terms of research, in terms of innovations, and also we are teaching some online courses as well. Recently, we are having two mega projects which we are dealing, one with Malaysia and one with Turkey, and we are directly connected with some drones related stuff with the international universities right now. And also I'm working with King's College London as a visiting researcher. A whole of my work with Professor Yangsha Ding at King's College London is about drones. So as I did work a lot about unmanned air vehicles in my life, so specifically when I was working regarding drones, so I will tell you that drone was the things that fascinate me a lot. I thought that when the era of drones was like just about to start and very few researchers was doing work in drones in the international community, I will say that I was also one of them when I started my work on drones in 2015. So that's why I thought that as everyone nowadays is working on artificial intelligence and especially machine learning, so I thought that I should do some innovation regarding drones to help out the international community and the researchers and to contribute towards the scientific world. So that's why I chosen the area of flying ad hoc networks, which I'm going to discuss right now in my next slide. Let me just, if I talk about the word flying ad hoc
Amazing.
networks, uh, is there any problem, Harchand?
No, sir. Continue.
Okay.
I was just saying that you have a lot of experience in your field. It's
Yeah,
an
thank you
amazing.
so much. Yeah, thank you so much. So, as I did earlier, told you about the area flying ad hoc networks. Like most of the people, when they hear about the word flying ad hoc networks, so they think that why, like earlier, Inam was talking about drones, and now he's talking about flying ad hoc networks. So, I will tell you that the word flying ad hoc networks, we can normally say that the combination of drones can make you the network, and that network is basically called flying ad hoc networks. Even in the common definition of a flying ad hoc networks, it is basically composed of unmanned vehicles which allow some great mobility and providing connectivity to the remote areas. If we are talking about mobility, so earlier, like most of the researchers did work on mobile ad hoc networks, vehicular ad hoc networks, and ship ad hoc networks. So every sort of area is having some sort of a specific mobility pattern, and that mobility pattern is basically pattern, as I did study in my as I'm a researcher regarding unmanned vehicles. So I did a lot studied about the unmanned vehicles, where I did study the mobility patterns and the normal mobility patterns which we see and study specifically for the flying ad hoc networks, which we can also refer to drones as well, are either called random walk mobility model, either like we can say column mobility model, which like recently one of my research publication also came on nomadic mobility model, and I did work on the 6 mobility patterns which is relating with the unmanned vehicles. So that was about the flying ad hoc networks, where unmanned vehicles are nowadays used in our like life, and like what sort of application unmanned vehicles are having. Because when we are talking about innovation and things, so we must need to facilitate humans in some sort of a way. Either the unmanned vehicles will be facilitating you in the photography, either like if someone will be having a family gathered function, if someone will be over there in a family function, if someone is having if someone wants to click some photographs, and if someone is having an adventure, so they can use quadcopters. We call that unmanned vehicle a quadcopter. The 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 things we are normally using in our day-to-day life, that are called that basically relies in the category of a quadcopters. When we are talking about unmanned vehicle, so we can call that either that unmanned vehicle will be either working on the area of civil applications or either in military application. When we are talking about the civil application, so it will come in the area of quadcopters. So the things we are normally using for medical purposes, or either for logistics, or either for agriculture, or even for some other things which humans can normally use it. So we call that quadcopters, because the the weightage of a quadcopter is quite like it's quite lightweighted, and they are not that much heavy in comparison with military drones, yeah. So some sort of a military drones you guys might see in the visual as well, that the military guy is having some sort of drone in his hand, and that drone is quite much small. Some sort of swarm-based drones are also, like most of the people are right now working on like military drones, and they are trying to develop some drones that can be using B ad hoc networks, I will say, because like they want to work on the B ad hoc network, like how the honeybee is working, like how the honeybee can make a comb, like how they did make the honey thing. So they are even some sort of researchers are nowadays working on to like make a drone just like a bee. So it's also like in progress, like these things. Also, I will say that recently Amazon and DHL did started some sort of application of a drones for the specifically for the logistics. And also I will say that Israelis like they are quite much working on drones specifically in the area of agriculture. So also I will say that for medical purposes, unmanned vehicles is having quite much applications, and we can use that for rescue things as well. Like if you want to rescue someone, if you want to see someone over there, if someone is having in danger, so you can use the unmanned vehicles. Apart from that, the main question arises when you're using unmanned vehicle as a application. So one thing you will be having that either the drone and the unmanned vehicle is connected with what? So basically the unmanned vehicle is connected with a base station, and the base station, like normally some sort of guys, they are having some joysticks, so you can call that joystick also a base station. But apart from that, in term if you are talking about the military drones, so the military drones are connected with some sort of a base stations, which base like these base stations I normally call that like computer connected like base stations, because they try to connect the a drone with a computer, and they try to operate each and every operation of a drone through that computer. And also, if the drone will be away from the line of sight, uh, like normally, if I do talk about the wireless communication things in between the drones and the base station. So the drones are basically wirelessly connected with the base station. So as we are talking about right now about the wireless communication, so they are having some very limited range. Due to that limited range, unmanned vehicles face a lot of things. So that's why unmanned vehicles are also connected to the satellite. How they will be connected with a satellite? It's a very like a simple question. I will answer this like, uh, let's say if the drone will be going away from the border area, or let's say if the area coverage for the drone and the base station will be hardly, let's say we will say that 18 kilometers. After 18 kilometer, it will be coming in the range of the line of sight. So when it come in the range of line of sight, so it will be directly connected with the satellite. And satellite are having direct communication with drone and the base station as well. In the pictorial view, you guys will see the smart city overview, which will you guys will be having the attacker and the victim as well. If you guys see the attacker, so the attacker can influence the drone energy, I will say. How they can like influence the drone energy? They used to do some sort of attacks like DOS attacks, DDoS attacks. They try to deploy these attacks on a drone, on specifically on a drone, and they try to reduce the level of energy of drone. So, which is a very serious problem. Basically, in my research, I did some experimentations about drones to level up and store the energy of drones. So that's why this pictorial view, you guys will be like seeing about the how the drone is becoming a victim, and the attacker is trying to attack on a drone, on a specifically on a drone, and the drone is trying to influence the other drones as well. Because let's say if one drone will become a victim, so how this victim drone can communicate with the neighbor drone. So this is the main flaw in the drone. Like we will say that the battery problem of a drone is very much huge. So this is a research gap. I will say that like reading a lot of papers and reading too many works, I did formulated that drones are having a battery problem. Even it will be a military drone, either it will be a quadcopter, they are having a battery problem. So how we will tackle this problem? I did some experimentations, and my works are published in international reputable journals. So what I'm saying, I will be saying everything by my preference. So let's move towards the another part. If we talk about the evolution, like how the if we are talking about the wireless communication in between the unmanned vehicles and specifically about the base station. So you guys like earlier studied, just right now you guys studied about the wireless communication. Wireless communication networks are over there in between the unmanned vehicles and the base station. Sorry. So when we are talking about the wireless network, so either the wireless networks will be either infrastructure-based wireless networks, either it will be infrastructure-less. When we are talking about the unmanned vehicles and the flying ad hoc network, so we are just talking about infrastructure-less in wireless networks. Because the thing deployed over there in between the base station and drones and satellite, you guys will see only wireless communication. So when we are talking about wireless communication, there you guys can see the band of IEEE that is called 802.11. Commonly 802.11 is commonly used in between the unmanned vehicle and the base station. But when we are talking about the swarm of drones, so the swarm of drones mostly they did use the technique that is commonly called multi-point relay. Multi-point relay is a technique like, let's say they try to make one of the drone as a leader, and they call it the like this technique is basically called the multi-point relay, that only that leader can like send the message and the things to the another drone. So this thing comes in the category of the multi-point relay, but this is specifically a technique. It's not a wireless sort of a thing or like that. uh, like in this slide, you just like we just talk about the wireless communication, what sort of thing they use over there in the unmanned air vehicles and the base station. So if we move towards the ad hoc networks, as I earlier explained about the flying ad hoc network, so I will say some common things about like the mobile ad hoc networks. Like earlier, the first communication technology when it came in our hand, that was mobile ad hoc networks. Researchers was working a lot on the ad hoc networks. They was trying to connect the things with each other. So they did develop the technology that was called mobile ad hoc networks. In 1970, the Bluetooth technology was quite popular with the American Navy, and they did formulated the thing of the Bluetooth, and they also did call that Bluetooth also 802.11, which is the basic standard for IEEE. Then after that, when the things was like getting developed, so the mobile ad hoc networks was having the static nodes. But in comparison with the static nodes, the researchers did work a lot on the mobile ad hoc networks, and they formulated a new thing that was called vehicular ad hoc networks. If you will be having a mobile on your car, and if the car is moving, and if it is moving from one city to another city, uh, they will be having a problem. They will be not having any sort of a problem. Why? Because like they will be using mobile ad hoc networks, because like the hands off can easily be like taken place, because like if you will be having a mobile and you will be moving from one place to another, so like no sort of a problem will take place just using regular ad hoc networks. So as researchers was like quite interested in like doing some sort of innovation, so they did formulated the thing that was called flying ad hoc networks. If you guys see in the pictorial view, the first thing you are seeing the minute that is called like static things. Then the another thing, it's a moving, but it's just on ground. But in the third picture, if you guys see that, that is basically flying things. So the flying things, I call it flying things or flying vehicles as well. So the flying ad hoc networks are connected with the like the drones are basically connected with the base station. So this was a basic introduction about the ad hoc networks. Like this is some of the literature as I did study it, and I did summarize some of the authors. So I will just go through some of them. I will not go and like go through the details of these things. Like when we are talking earlier, when I did started communication with Harchand, and we was just trying to talk through a specific channel. I will say that English was the channel we was using. So like when the technologies was growing and everyone was like thinking that how to communicate with someone. So the word how to communicate with someone, they did formulate some sort of a routing protocols. Commonly, if I talk about a routing protocol, so you guys can say that routing protocol, what is routing protocol? Basically, a routing protocol is a thing, like let's say, if I'm talking with a Harchand or Osama or anyone else in a specific language, so that specific language, you guys can call that a routing protocol. So a routing protocol can be like so many, like if we are talking about like the energy based routing protocol, so we will talk about leech. If we are talking about like some other like hybrid sort of a protocol, so some optimization techniques can be used. So many researchers did work in the year of 2018, 2017, and 2018, and so on. They did worked on so many simulation tools and things, and they did formulated the things about like the in these 2 3 slides you guys will see the contribution of a lot of researchers and authors that they did work on some routing protocols, and also they did work on some like ad hoc networks. Either they are working on Internet of Drones, either they are working on flying ad hoc networks, either they are working on UAV networks, either they are working on IIoT. IIoT means like industrial IoT. Like so many people worked on these things. So I extracted some of the routing protocols, and I summarized the things about some of the routing protocols, and even I did experimentation about I did experimented about 60 to 70 routing protocols till now, and I did use network simulator too and MATLAB while doing the experimentation regarding routing protocols and the things. So I did use some. I will say that AntHognet. AntHognet is basically a nature-inspired routing protocol, uh, dynamic source routing, temporary ordered routing algorithm, MDART, and DHDV as well. So these are some sort of a routing protocols which are commonly used. So you guys will thinking right now that Sir Inam did worked a lot in routing protocols. So he just worked on existing routing protocols? No. My answer will be I did work on existing routing protocols to study their behavior, how they are having their behavior in packet received ratio, how they are having problem with in-twin delay, how they are having problem while they are receiving their packets. So we can call that throughput, and also about overhead. So the things happen that I did formulated my own routing protocol. What was that routing protocol? That was a brief overview, like nthognet basically work on a form intelligence based technique. Dynamic source routing is having like three basic things, which is called reactive, route scouting, and flooding. And the another thing, temporary ordered routing protocol is multi-path reactive strategy, and MDOT, multi-path dynamic address routing protocol, also is a proactive strategy, working on the extension of DOT. And the same thing, if we are talking about the DSDV routing protocol, so it's a table driven. It is having a Bellman Ford algorithm. Just think about it, most of the I think engineers and everyone will be trying to they will be listening my right now my lecture. So if I'm talking about this, so you guys must have to keep in your mind that every routing protocol is having different behavior. Either the routing protocol will be reactive, either the routing protocol will be proactive, and some of the protocols are hybrid also. Hybrid protocols are having the functionalities of a proactive and reactive both. So I did study so many things, and in my problem statement, I did formulated, and I did surveyed some of the gaps, and I thought that unmanned vehicles are having shorter lifespan, and they used to take huge time while they are processing some things. So the unmanned vehicles can't communicate with each other. They don't have any language. So I thought that why not I should be the person to make a specific language for unmanned vehicles. And I also find one of the another gap, that was weak signal strength in between base station and unmanned vehicles. So these are some of the gaps I did found. And the routing protocol which I developed, it was very much sensitive to the packet drop, and it was not having any problem while variation in delay. And my routing protocol, which I named it E and Hognet, it is working on the basic principle of n colony optimization. Like it means that if in a common and layman language, if I say about the routing protocol, so I did made one of the routing protocol which is having the knowledge and understanding of a ant colony, like how the ants can move from one place to another place, and how the ants can find their food from their home, and how they try to search for their foods. It's all the game of ant colony optimization. It's like that. So basically, the ants are having they are dropping from their mouth a pheromone, and they are basically blind. So the whole strategy of my routing protocol is relying on ant colony optimization. So this is the algorithm I did made, and I did embedded one of the major thing which I contributed in the international community, which was the energy stabilizing threshold. If you guys look at the algorithm, so this algorithm is having the phenomenon called how the regularly the pheromone can update. Pheromone is basically called, like you can say that if a person is having saliva, so the exactly the ants are having pheromone. So if the pheromone is like repeatedly like dropping from their mouth, so they are having a very clear path. Because they are blind, they can't see. They just work on the level of the pheromone. If the level of the pheromone will be high, they can move easily through that pheromone. But if the level of the pheromone will be quite low, so they cannot move from one place to another, and then they are basically blind, so they can't see. So I thought that I should formulate the energy stabilizing parameter. I thought that I should make a threshold. That threshold, if that threshold will be quite high, so it will give me an alarm. Okay, how it will be giving me an alarm and how they will be trying to update the neighbors as well. Let me tell you about the steps of a ant hoc net, which I did formulated and which is even available on internet in the journal of IEEE access. So if I talk about the E ant hoc net, the word E, I used E with the ant hoc net, that is called enhanced ant hoc net. This algorithm steps consist of initialization of some parameters, having some how to generate a feasible solution. So basically, the ants used to do the housekeeping stuff, like they try to find their food. Uh, Normally, when the pheromone, if the value of the pheromone will be greater than zero, so it's a good sign. If the value will be higher than zero, so they can easily like go from one place to another. Let's say if the evaporation will be quite low, so then they can move. But if the evaporation will be quite high, so they cannot move from one place to another. So it also works on the concentration of a pheromone as well. And also, as we are talking about the pheromone, so in the normal routing protocol, routing table is updated, but in my algorithm, you will see that the pheromone table can be updated easily. So this is the topology I did made, and I did worked on about 30 drones. In this topological scenario, you guys will see about 30 drones, which are 30 drones are did connected with the base station, and I did worked on these 30 drones. Okay, so I did deployed my algorithm over there in these drones. So some of the parameters I did use in my simulation work, which was like simulator or like the software. I did use the network simulator too, and the simulation time it was 180 seconds. The topological scenario or like the topology area, so you guys can see that the topology area. So you guys can see that drones can move from one place to another in three-dimensional environment. So that's why the topology area is three-dimensional, and the packet size is 512. And I told you guys that I did use about 30 drones except base station, because like with the base station it will be 30 nodes, and the initial energy of each drone was 75, and traffic type was a constant bit rate. So if we move towards my formulation, which I did made, I will not say that I'm that much a good scientist, that I did worked on a formulation regarding the energy stabilizing threshold. I will say that that was Einstein, that he also made one of the formula, and that formula was that much capable that right now the whole world is having the atom bomb and like these things. So I will not say that I'm that kind of a caliber in that caliber, but I will say that I did work in my PhD and I just formulated this formula. I will say that that was work of about 1.5 years, and I did made this formula that was about energy stabilizing threshold. In this formula, you guys can see that the IE is having the drone's initial energy, A, B, and C is having the X, Y, and Z dimensions, and the total number of nodes. So this formula can easily give you the 25% storage. Okay, like let's say if the drone will be having 100% energy, so when 75% drone energy will be used, so the drone will automatically send a message to the base station. So this is the formula which can save you 25% of energy in drones. So if we do towards the formulation of this problem, or like a formula, so if you like, as I did mention that I did use the initial energy of drones, that was 75 joules, and the total number of nodes was 31. So the x, y, and z dimension was 1000 meters in each. And E is basically called, like, you can say that it's a natural log. Natural log is having the specific, exact, and by default value, which is 2.718. So if you guys see, so when you guys do the whole like formulation, so you guys will easily save 25% of joules. It means that through my formula, you can easily save the level of energy. In each round, you can save the level of energy. These are some of my simulation results, which I did compare with using my own formula. I did incorporated the formula in NHOGNet, and I call that ENHOGNet. So that's why I did compare my protocol with the other routing protocols, and you guys can see that a percentage increase in comparison with the ENHOGNet is like quite good. So the packet drop rate was quite low in comparison with the others. If we talk about the throughput, so throughput means like the how many packets are received with, like, in how much time. So ENTOCnet is having the best results in comparison with the other routing protocols. So if we talk about delay, so in delay also ENTOCnet is also having a better results. Um, some like Tora and DSR is also having good results, but as a whole, if we see, so E and Tognet, which I did formulated, so it is having the best results. So in E and Tognet, we did use the energy stabilizing threshold to modify the ant hello packet and update the neighbor tables, which used to conserve the drone's energy and improve the overall lifetime as well. So we can call the quality of service, like if you guys do add 2 to 3 parameters, so you every researcher can call that a quality of service or quality of experience as well. So my quality of experience in the E and HOGNet was throughput, end-to-end delay, and packet drop analysis. So some of the like you guys directly saw in my formulation and also in the simulation results that drones easily save 25% of energy. So if we go towards the second like phase of the this session, so it is basically on a receive signal strength using this signal tree. Like in our topic, you guys can see about artificial intelligence. So artificial intelligence, in artificial intelligence, I basically selected one of the area that is called machine learning. In machine learning, I did use the algorithm that was decision tree. And I will say that the drone in this pictorial view, I will talk about the base station and drones communication. They are using the wireless communication uh, link, and that wireless communication link can be improved using this tree, which I did some of the visualizations. Let me show you the visualization. Like first, you guys can only see the base station, and with the base station, some drones are connected with the base station. So if the drones will be moving away from the base station, what will happen? The drone signal strength will be decreasing, because with the passage of time, as the drones will be moving away from the base station, so they will be having problem with the communication links. So that was the point that I did decided that I should improve the communication link in between the base station and the unmanned air vehicles. So that was the thing that I did worked on decision tree to improve the signal strength in between base station and drones. So basically, I did used for this experimentation about the localization technique, which is using the angle-based localization and receive signal strength. With angle-based localization, you guys will try to check the position and height of each drone, And also you guys can do practice and like do experiment this thing in indoor and also in open door as well. So we try to measure the distance of nodes. Okay, so how we will be trying to measure the distance of drones? We will be trying to use that through receive signal strength. So normally, as I did earlier, told you in the initial slides that normally every drone try to use the basic technology that is called IEEE 802.11. So I used the Zigbee wireless technology, which is having the approximately range in indoor is about 30 meters. Okay, and the normal distance ranges from 10 to 100 meters. In Zigbee is very much secure. It is a very low cost. It is a up-to-date technology. That's why I did incorporate that in the unmanned vehicles to enhance the signal strength in between the in between basically the base station and unmanned vehicles. So if you guys see the Bluetooth and the Zigbee comparison, in the Bluetooth and Zigbee comparison, like earlier, the Bluetooth was quite short range. It was not that much fast. So in this graph, you guys can see that Zigbee is having a fast data coverage. Zigbee can be long range. So that's why I did use Zigbee. In the second experimentation, I did use MATLAB for my experimentation. Earlier, I did use Network Simulator 2 for my experimentation, and I used decision tree in the 2D and 3D based environment. So these are some of the my results, and I did find the actual distance, and I did calculate the receive signal strength. If I tell you honestly, so like how much like I have improved the signal strength. So let me show you the comparison slide. In this comparison slide, you guys can see that hardly 1% signal strength I have improved in between the unmanned vehicle and the drone by using this signal tree. Earlier, some of the researchers they did use that in 2018, and they did improve the signal strength using wireless sensor networks. So I thought, why not in drones? So I implemented the things using decision tree, and I improved the whole signal strength from unmanned vehicles to base station. So that was about the wireless technological things. So that's why routing protocols are very much efficient for the communication in between drones, and the thing I improved in between base station and drones, you guys can use Zigbee and also can use my algorithm. Like I did use the 3D centroid algorithm by using decision tree to make the signal strength more and much improved. So if we talk about the future work of this section, so I will say that so many work, so much work we can do in the area of unmanned vehicles, and I think we can do improve the signal strength more from land station to aerial vehicles. We can do make the hybrid mobility models till now very like I told you earlier that there are hardly 6 mobility models available in the area of unmanned vehicles. So if someone is interested in the area of unmanned vehicles, I will say that they can do work on the hybrid mobility models. And also I did saw in the area of research that very like no one is working on the security based routing protocol. So if someone do work on the security based routing protocols, that will be the best thing. And these are some of my publications. You guys can like search that on internet. And the first paper, if you guys see over there, it is published in the IEEE access, and this article is basically on and topnet. And the second paper, if you guys are seeing, so it is about the decision tree thing, which I did improve the signal strength. And I'm having about 45 research articles. So some of the research articles I did mention over here, and recently I'm editing one of the book with the Springer. One book I did formulated and I did compiled with Springer right now, and my second book is open for book chapters. You guys can contribute towards in the area, specifically in the area of big data and cybersecurity. That is about my second book. And like I will not say that these are my like two books, but earlier I also authored one of the book on ant colony optimization, which is available on Amazon. So you guys can download that from Amazon as well. Even I did freely available. My first book is even freely available on ResearchGate as well. So the topic of that book is route optimization with the ant colony. So it is published over there in Germany. So these are some of the references for my session, and the code which I did use. So whole of my code is available over here. You guys can download the code from this GitHub, and the other data is also available. Thank you so much for the session, and thank you so much for inviting Harchand, and especially thanks to the community of Engineer Talks. And I will say thanks especially for giving me the opportunity to talk in front of everyone over here, and especially for giving me the honor to be on board with you guys as a advisory committee. So thank you so much for everything, and thank you so much for listening me. So if you guys are having any question, you guys can ask.
Thank you so much, sir. It was an amazing session. There are some questions from our, we can say, our audience. Like some
Okay.
of the audience are asking that you talked about military drones, and if you can show them a real images of their work and their application, it was a good example for them.
Yeah, that will be quite good. I just use some of the applications over there. So I will say that one of the guy, he was holding the swarm drone. Okay, the swarm drones are quite much like small in size, and they are having the things. But if you are talking about military drones, so military drones, we can say that they are quite heavy. If I talk about the one of the drone, theoretically, I will say right now I'm having only one image in my presentation, so I will show you only that image, and I will tell you one of the story about the drones, which is quite famous, and it was done in 2011. In 2011, the thing happened in between the Iran and America. America was trying to take some of the footages of their nuclear power plant, and they was trying to invade the things through drones. So America did what? America sent some of the drones towards Iran, and like I will say that Iranians was also quite so much sharp. So in 2011, that was the drone R RQ-45, RQ-45 Parrot drones. These drones are so much expensive, like in millions, the price of that drone is. And basically, I did say it about the DOS and DDoS attack. So the thing, Iranians did what? Iranians deployed the attack of a DOS DDoS attack over that RQ-145 drone, Parrot drone, and they did hack the whole drone using the DOS and DDoS attack. So that's why the security sort of a thing is like I will say that drones are so much vulnerable. They are having so many weaknesses, and especially security is the biggest weakness in the unmanned vehicles. So in this image, you guys can see the military guy having the very small drone. So it's a swarm based drone. Right now, I'm not having any footage about the military, like big drones, like the way I told you about the RQ-45 Parrot drones. They are so much expensive. And even I told you about the story as well. So if someone is having interest in unmanned vehicles, I will be happy. And if someone wants to contribute, so so they can directly contribute in my book as well. So any other questions?
Yeah, thank you so much, sir. Another example, another question from our audience that I am doing in doctoral research and business strategy and keen to get thesis in drone. If you could suggest me topic. Uh-huh. It is
Uh,
asking about that some suggestions for their topic.
okay, so she's doing PhD in management sciences.
Yeah, I think so.
Harchan? Okay, if she's doing PhD in management sciences, I think through drones, if they like, if someone is going to study the studies of a drones in the area of management sciences, so I think logistics, like even in the pictorial view, you guys can see that right now Amazon and DHL are using the drones for their logistics. So if they do some case studies over drones, like especially like to relate the humanoid things, like how the logistics was, like how the parcel was moving from one place to another through human, and right now through drones. So if they do compare these two things and they do work on the logistics using unmanned air vehicles, so I think this will be a very good idea for PhD.
Okay, thank you so much, sir. And yeah, there's no any question. So it overall it was an amazing session, and personally I learned a lot of things from drones and from ADOG network and about routing protocols. Yeah, thank you so much, sir, Inam, for your precious time,
Welcome.
and thank you so much our audience for listening this amazing session.
Welcome always. Thank you so much. Meet to you inshallah next time. Take care.
Take care, sir. Thank you so much.
Take care.